If you're building AI agents, you eventually hit a wall. Running an automation script on your personal laptop works fine for testing, but the moment you close the lid, your internet drops, or Windows forces an unexpected reboot, your agent goes dark. To fix this, you need an environment built for constant uptime. A virtual private server gives your agent a dedicated remote home that stays online 24/7. In this video, we are going to build a fully independent automation system. We will secure a fresh remote server, deploy a completely private local AI model, and wrap it in a system manager so the agent automatically restarts itself if it crashes. Running an AI model directly on your own infrastructure requires serious memory. You will need a server with a minimum of 16 gigabytes of RAM to handle even the smaller local models effectively. Meeting this strict hardware requirement transforms your AI into a permanent, sovereign infrastructure asset that continually works while you sleep. Step 1 is getting into our new server environment. Open your terminal and SSH into your fresh VPS as the root administrator. Before we install anything, we have to establish basic hygiene. Run the standard apt update and upgrade commands, then create a brand new dedicated user. We will run our agent from this new profile to isolate its permissions away from the root system. Now, we need to lock down the network. But before you turn the firewall on, you must explicitly allow open SSH traffic. If you skip this exact command, the moment you activate the firewall, you will permanently lock yourself out of your own server. With SSH secured, run the command to enable the uncomplicated firewall. Once it is active, safely transition away from the root account by switching over to your newly created secure user profile. Let's verify our work. Check the firewall status and confirm that port 22 is open and actively listening for connections. AI agents frequently handle sensitive API keys and database credentials. Operating an internet-facing automation from a restricted user account behind a strict firewall is the mandatory foundational layer for any production environment. Most beginner agents send data out to an external API. We are going to process everything locally. Hosting your own model ensures complete control over your data. To do this, we'll use Ollama. You can download and execute its official installation script directly in your terminal with a single curl command. Once Ollama is installed, instruct it to pull and run our specific target model, Llama 3.1-8B. This is where your hardware choice matters. If you attempt to load this model on a small, low-RAM server, the system will exhaust its physical memory and aggressively spill over into swap space, completely freezing your terminal. If your server has the required 16 gigabytes, the model loads smoothly. You'll see the Ollama chat prompt appear, confirming your local AI is active and ready. Next, we need to build the software that will actually talk to this model. Install Python 3 along with its virtual environment utilities. Create a new virtual environment inside your project folder and activate it. This strictly isolates your agent's software dependencies from the core operating system. Inside this isolated environment, use pip to install the requests library for handling network calls and python.env to securely manage your environment variables. Now we write the agent logic. Instead of pointing your code at a paid external API endpoint, you structure your Python script to route its requests directly to Ollama's local port on your server. Run the script manually in your terminal. You should see it successfully connect to your local model, process the prompt, and output the result. The agent works perfectly right now, but there is a major problem. The exact second you close your SSH session, this entire Python process dies. To keep it alive, we need a system-level manager. That manager is Systemd. It is a native Linux utility designed to detach your script from the active terminal session and force it to run continuously in the background. Open your text editor and create a brand new service file directly inside the etc systemd system directory. When you configure this file, you must be exact. Systemd requires absolute file paths. You have to spell out the exact full directory path for both the working directory and the execution command, or the service will fail to start. Next, we make the agent resilient. By adding the directive restart equals always, along with a 10-second delay, Systemd will automatically revive the process if it ever crashes, while pacing the restarts to avoid overwhelming the server in an endless loop. Save the file. To deploy it, reload the system daemon to recognize the new configuration. Enable the service so it boots automatically when the server restarts, and finally, execute the start command. Run a quick status check. You should see a bright green active indicator. By doing this, we've elevated our logic into an integrated system daemon that governs its own continuous uptime. To prove it's working while you're away, use the Journalctl command to tail the live logs. You'll see a steady stream of completed tasks logging silently in the background. You now have mechanical resilience. If your Python code encounters an error and fails, the system restarts it. If the VPS restarts for an update, your agent boots up right alongside it. Because we paired this persistence with a local model through Ollama, all data processed by this agent stays entirely on hardware you control. You get total privacy with zero external API costs. You have successfully built a sovereign automation asset. All the specific commands, server configurations, and setup scripts you need to immediately replicate this build are down in the video description.